A warm welcome to Module 3 of Exploring Parallel and Intersecting Lines. Our focus today will be on adjacent angles. After this module, you will be able to identify and name adjacent angles, apply their properties in conjunction with other angles to find the missing values. So let's go ahead. Before we dive in, let's quickly recap what we covered in the Module 2. Angles have two parts. One is the point of intersection where the angle is formed. The lines or the rays are anchored at this point and it is called vertex. Can you identify the vertex of this angle? Exactly, O is the vertex in this case. And then there are lines or rays which tilt or move or rotate to form the angle. These are called the arms of the angle. That means whenever you have to name or define an angle, you have to mention the vertex and the arms. So which are the arms in this angle? Absolutely right, OA and OB. So vertex and arms are the two parts of an angle. Observe the angle on the screen. Can you identify its vertex? Absolutely right, the vertex is O. In naming an angle, the first step is to identify the vertex. And in angles like these, where only one angle is formed at the vertex, we can simply name it by mentioning the vertex, that is angle O. So it's perfectly fine to name this angle as angle O. But in some cases, multiple angles are formed at one vertex. In that case, we have to name the arms also. So how will you name this angle O using its arms? Can you write in the comment section? It is simple. O, the vertex always has to be placed in the center or the middle, and the name of the arms can be placed on the either side in any order. So the name of this angle O can be angle AOB or angle BOA. All three work perfectly fine. Let's make angles more relatable. Imagine four people A, B, C and D sitting around a table. Who is sitting next to A? On the right of A is B. On its left is D. Both B and D are sitting next to A. Or if we may say, B and D are sitting adjacent to A. Let's apply this to angles and explore adjacent angles, our topic of the day. Let us run a test to check if the two angles on the screen are adjacent or not. But first, can you name this angle pair? Of course you can. And if you are feeling unsure about it, don't worry. Go back to module 2 and come back when you are feeling confident. It is essential to get the naming part correct. Coming back to our angles, we see two angles on our screen, angle AOB and angle BOC. The first test we are going to run while finding out if they are adjacent or not is to check if they have a common vertex. So look closely and observe the image. Are both these angles getting formed at the same vertex? Exactly, they both are getting formed at the common vertex O. This we have seen through the illustration. Now let us examine the name also. If you read the name angle AOP, you can see that O has been placed in the middle. That means this angle is getting formed at O. Similarly, angle BOC is getting formed at O. So we should be able to connect the illustration with the name and we should be able to comprehend both. So from the name also we can say that they are sharing a common vertex, and from the illustration also it is clear they are getting formed at O. So the first test has been passed. They share a common vertex. We are checking for adjacent angles and we have already got our common vertex. Examine the names on the screen and find out if they share a common arm. If you read the names closely, you will see that OB is getting repeated in both the names. And if you look at the illustration also, you will see that OB is like a divider between both the angles. Hence, we can say that they share a common arm named OB. So this test also is passed by both the angles. So while checking for adjacent angles, we found that both angle AOB and angle BOC have a common vertex, that is O. They have a common arm, that is OB. So both the tests are passed. So let us move on. Let us identify if these angles have non-common arms. Observe the names closely and you will find the answer. OB is already common to both. That means OA and OC are the non-common arms. These arms, if you look at the illustration, are exclusive to their respective angles. OA is exclusive to angle AOB and OC is exclusive to angle BOC. What are we looking for in non-common arms? We are looking for their position. So OA and OC are the non-common arms. But are the non-common arms positioned correctly? What is the correct position? They should lie on the either side of the common arm. Common arm is OB. So are these non-common arms, the ones that are crossed, are they on the either side? Which also means that the common arm should lie between the non-common arms, as illustrated in the picture also. You can see OB is like a divider between both the angles. This is the exact position we are talking about non-common arms. But what does it actually mean for the angle? Let's observe. Non-common arms on the either side or common arm between the non-common arms. So this means that both the angles will not share any common points. There won't be any overlapping. These pointers and questions are assessed in different ways through MCQs. So we have to make sure that the angles we are examining should not have any common points or overlapping. Angle AOB and angle BOC have a common vertex at O. They have a common arm OP. And the position of non-common arms is on the either side of the common arm, or we can say the common arm lies between the uncommon arms. So OA and OC lie on either side of OB. Since all the three tests have been passed, we can now conclude that these angles are adjacent angles. Let us check how much we have understood. Now it's your turn to find out if angle 1 and angle 2 are adjacent angles. You may please pause the video to match your learning pace. First, check for the common vertex. Does it exist? Both angles are getting formed at the same vertex. So common vertex exists. What about the common arm? Are they sharing a common arm? Absolutely correct. And is the common arm lying between the non-common arms? Exactly. All three criteria are met, and hence we conclude that yes, both angle 1 and angle 2 are adjacent angles. Is angle AOD adjacent to angle AOC? Pause the video and explore both the angles. Start from the vertex and look if the common arm OA lies between the non-common arms. So the common arm is absolutely right. The common arm, as specified in the name or even in the illustration, the common arm is OA and it is lying in between the non-common arms. So yes, we can conclude that both these are adjacent angles. Let's do one MCQ together. The angle that is adjacent to angle ABD is, so the options are there in front of you. First thing, you have to see that this angle should have a common vertex with the adjacent angle. So even before you start reading the name in the image, you can quickly go through the options and see if any of these have B in the center. I can see there are 3 options with B in the middle. That means any of the 3 can be the correct options. Of course, D cannot be the correct option because the common vertex is missing. Now I look for the common arm. Either AB or BD should be present in the correct option. So can you now, just looking at the name, can you find your answer? Correct. The first option appears to be correct, but do check it with the illustration given. It is just a hint, a clue, or a prompt for you to help you find the answer, but illustration has to be checked. Let's see why. So, is angle MLO adjacent to angle MLN? Now, we are not referring to any illustration, any image, just from the name only. Let us see. Are they sharing the common vertex L? Yes. ML common to both? Yes. LO, LN are non-common arms? Yes. So, going by those features and characteristics, we can say that both the angles should be adjacent. But how do we know the position of the non-common arms? Are the non-common arms on the either side? Common arm must be in between the non-common arms. So we will have to refer to the illustration. If you look at the illustration, the common arm LM is on one side. It is not in between the angles, not dividing the angles. Hence, they are not adjacent. So this also shows that we have naming helps us, but eventually we will have to follow the illustration as well. We must refer to the image also. So let's conclude. Adjacent angles share a common vertex, have a common arm, and the non-common arms lie on the either side of the common arm, or the common arm lies in between them, one and the same thing. But do we see adjacent angles around us? Can you relate to certain angles that you see around you all the time? For example, the minute and the hour hands of a clock. They form adjacent angles with the center of the clock, serving as the common vertex. They are all attached to one center. The 3 hands are attached to one center. So this is an example of adjacent angle. Even your notebooks and your books, when a book is open, the pages form adjacent angles where they meet at the spine. The spine of the book acts as the common arm, and the corner where the pages meet serves as the common vertex. Folding a piece of paper to make paper planes, a fun activity, and it also forms intersecting creases form adjacent angles. And the wings of an airplane are attached to its body for a good lift and allow the plane to take the flight, and they are also set at adjacent angles. Stay in the video till the end to show off your math skills by attempting the rapid fire round questions. And I am now leaving you with questions that will challenge your understanding. Put your pen to paper, music on or mute, whatever helps you focus. Take your time and let your math progress shine and reflect. Join me in the next module to discover the special angles formed by 2 intersecting lines. Until then, keep learning, keep practicing, and stay curious.